Good morning, guys. Today would be Thursday, December 10th that you're watching this, and today we are talking about scatter plots. Scatter plots are a type of graph where we have a bunch of data on that graph, but it's not really in any concise fashion. It's not a straight line. It's kind of dots everywhere. I guess if I just show it to you, it'd be easier. Kind of looks like this. There are just little dots everywhere. And our goal is to do a couple of things. First, we want to talk about correlation. So I guess a scatter plot is a graph used to determine whether there is a relationship between paired data. Scatter plots can show trend in the data. If it tends to go upwards like this, just like puff puff positive, it has a positive correlation. If it goes downwards like this, it has a negative correlation. And sometimes you'll have a scatter plot that's just kind of all over, and that doesn't have a correlation. So you can have a no correlation graph, but we're kind of just looking for how that data is trending. So we can represent a data as positive, as negative, or no correlation. And we can even be more specific where if we're looking at graphs, if all the points are on going in a positive direction, they're really kind of tight to each other, we see that as a strong positive correlation. We can also see in this graph that it's going uphill, but they're kind of spread out more. That would be a weak positive correlation. Once again, if the points are just kind of everywhere, there's no correlation. It's going downward. It would be either a weak if the points are everywhere, or a strong if they are kind of tight to that line. So those are the different types of correlations. So what our problems will look like will be like here. Tell whether X and Y show a positive correlation, a negative correlation, or a relatively no correlation. So if you look at this one, we have a point there. They're not really in a line. They're not really showing any sort of a pattern there. So this would be a no correlation graph. There's nothing correlating here. So no correlation. On this problem, you can notice it's going uphill. That'd be a puff puff positive. So this would be a positive correlation. And if we want to be more concise, I would say that's a pretty tight, if I draw a line of best fit, which we'll talk about later, they are pretty tight to that line. I would say it's a positive strong correlation. It's both positive and it's strong. And on this one, it is going downhill. So this would be a nice negative correlation. And when it comes to the positive and negative, it's pretty easy to tell. The strong or weak is kind of a opinion. I would say that overall, I would say that's a pretty strong correlation still. They're not way out here. They're within a couple units away from that line. Negative strong correlation. This is one of those things, if you're asked it in class or a test or a quiz, it's going to be pretty evident if it's strong or weak. It's not going to be one of those iffy ones. If it's one of those iffy ones, as long as you can justify your answer to me, it'll be right. So the next one says we need to create a scatter plot, and we then need to describe the correlation of the graph. And all we have here is a quadrant, the first quadrant of a coordinate grid. So our X is our horizontal, and our Y is our vertical. So I'm going to go here, and when I make my graph, I am going to label my intervals of 1, 2, 3, 4, 5, 6, went too far, 7, and 8. I think it was my biggest, yep. And then, I guess 6 is my biggest, so I've been good. My Y value goes up to 8, so 1, 2, 3, 4, 5, 6, 7, and close enough, 8. So I'd have to point out 1 positive 2, 1 3, 2 4, 3 4, 3 5, 4 5, 5 5, 5 7, and 6 8. So I have now plotted my point. So I've now created a scatter plot. And looking at that, our first decision is to make a choice if that's positive, or if that's a positive correlation or a negative correlation. Just like slope-land, it's going uphill. So this would have a positive correlation. And if I draw a line of best fit, and I'll explain that more later, through the middle of the data, I would say that those points are relatively close to that line. So I would say that would have a positive, strong correlation. Positive, strong. So it's going uphill, and they're close to that line. Let's skip that one. The next one says using a line of fit to model data. And this slide reads that says make a scatter plot of the data. Decide whether the data can be modeled by a line. Draw a line that appears to fit the data closely. I don't know why I go back and forth between data and data. There should be approximately as many points above the line and below it. So this is the point. This is the key part. When we have a scatter plot, we have points. We want to draw a line of best fit, and it needs to kind of split that data in half. So half the points are above it, and half the points are below it. And we are then going to write an equation to model that line in slope-intercept form. The points do not have to represent actual pairs, but they must lie on the line of it. Okay, so let's see what that actually means here. So let's graph our points and draw a line of best fit and write an equation for our line of best fit. To be -2, +4, -1, 2, 0, 1, 1, -2, 2, -1, and 3, -2. So there we have the points of our graph. And our next job is to draw that line of best fit. I'll be right back. I'm going to grab my meter stick, if I can get to it. And so right now what we should be deciding and thinking is where would a line be that goes between those points. So that wouldn't, and we want to draw it so it kind of cuts the data exactly in half. If there's 5 above and 4 below, that's okay. If there's 5 above and 3 below, but it's close, that's okay. We just want to do our best job of drawing a line that cuts the data straight through the middle. And since we have to write an equation of a line, we're going to do our best to kind of like, I wouldn't say cheat, but make it easier ourselves. I can draw it probably like right there, but where's my line going to cross? It's going to cross like just below the 1. Let's do our best when we draw a line of best fit to maybe have an easy y-intercept. It won't always happen, but if we can, why not make it? So I'm going to draw my line, I think, right about there. So there is my line of best fit. If I need to write an equation for that line, it'd be y equals, well, we know it crosses at +1. So all I have left to do is find the slope. And if we look at some points, up 1 over 1, up 1 over 1, up 1 over 1, it looks like our slope would be 1 over 1x, or y equals 1x plus 1, or y equals x plus 1. So really all we're trying to do here is draw a line that cuts the data kind of in half. If you notice I went through points here, I won't always go through points. It just worked out that this one was kind of that way. But I want to draw a line that goes through the points, splits it in half, and then write an equation for it. If I'm looking at this, I would say this would have a strong negative correlation. It's pretty strong, and it's negative. Let's go to the next one. We have 0, -4. We have 0, -3. We have a half, -1.5. That's a fun one. 1.5, 1. Yep. 2, 3. That'd be right there. And 2.5, 4. So there is my line. My points. Now I need to draw a line of best fit, a line that kind of goes straight through that data. So I'm going to go right about there. Once again, if you can make it easy for yourself to go through a y-axis at a good point, do that. Let's go like right there. Hopefully you can see that. I'm marking it right well. Don't know if you can hear that. That was a beautiful sound. So my equation would be y equals, crosses at -3, so it'd be a -3 as my y-intercept. And if we look for some good points, I would say maybe from here to there, I go up 1, 2, 3 over 1, up 1, 2, 3 over 1. So that's pretty good. So I'd be left with 3x minus 3.
All right, let's get ready. Every single person, let's go. I'm going to play you some music, get dancing down those hallways, and make your way to the gym commons.
I'll be back.